Okay, let's start from scratch. So first we are going to grab our C# component, and if you remember, we said that we are going to grow our tree so it becomes bigger and bigger each iteration of our program. And now the challenge is how we can get our C# component to produce a different output each iteration. And we are going to achieve that with the timer, which we can find under parameters utilities right here. So what the timer does is that when we connect it with the C# component, or basically with any other component, it will execute this component once each second in this case. And we can activate and deactivate our timer if we make double click into it, like that. And we can also change the time interval that the timer is executing the other component, like that. But let's leave it like 1 second by the moment. And now we're going to use an example to show how this actually works. So let's define a variable here, iteration count. And what we are going to do is to increase this variable by one each time we are executing this component. So let me copy this, like that. And finally, we have to assign this variable to the output parameter A. And if we go back to Grasshopper, we can connect the output with a panel here. But now we see that the actual value of this variable is not changing. So why is that? I mean, why is this not working as we wanted? So the problem here is that we are declaring this variable as a local variable inside of our run script method. And we said that our scripting component is running this method each time that it's been executed. So what we are doing is declaring this variable again and again and again. So each time it's 0 and it increases its value by 1, but the next time it will be 0 again and again and again and again. So in order to avoid that and let this variable grow, we have to declare it not here but underneath as a global variable. So here underneath we can define our global variables, and they are going to be declared just the first time that we write the program and Grasshopper compiles it, and later on when we change the input parameters, Grasshopper is going to run just this run script here. But Grasshopper is not going to do anything else with what we already wrote underneath. Okay, so let's go back to Grasshopper, and now we can see that we're actually changing the value of this variable each time that the timer is executing our scripting component, and that's fine. But now we need some way of controlling this output value. So how we can restart our animation basically. So for that, I'm going to define a new parameter here, which will allow us to reset our animation. And of course, it has to be a Boolean parameter. And we are going to control this with a button, which of course this is a native Grasshopper component. And we can connect this with a panel here in order to see how this works. So basically, when we are not pressing the button, we are getting the false value out of it. And if we press the button, we get the value of true. So of course, we can use this button perfectly in order to reset our animation. So let's connect the button with our C# component. And now what we are going to do is to use a conditional. So let's say if reset is true, and if you remember, we don't have to write if this is true, because since this is a Boolean, it's already implied here. And now we can specify the conclusion that we are going to set this variable to 0 again. To 0. Okay, so if this is working, okay, the timer is increasing the value of our variable each iteration. And now if we click on the button, we are resetting the value. So it seems like this is working, and now we can control not just this animation in this case, but a lot of different cases. And we can also change the interval to see that, okay, this is working perfectly, and we can reset it again and again. And if we make double click into the timer, we stop this and we can reactivate it by making double click again. Okay, so now we already know how we can control our animation, and we can define the other input parameters for this script. First, let's define the origin of our tree. That will be a point here. Okay. And now I have to define other global variables. So let me write that those are global variables. And I'm going to copy some lines to go a bit faster, but if you are writing along the way, feel free to pause the video and take your time. So basically we are going to define a double, which will be the angle of the new branches, and we are using the math library in order to get the value of p. And we already used this library here, and of course it lets us access a lot of different interesting mathematical functions. And we are also going to define a list of lines that are going to be the branches, and a tree that is going to be the actual object tree of the animation. And of course you can find more information about lines and data trees inside of the Rhino command that we already saw. Okay, so that were our input parameters or input variables, and now we are ready to define the function that will let our tree grow.